is that you have your null hypothesis, and then when you reject your null hypothesis, you're going in one specific direction, as opposed to a two-tailed test. You have your null hypothesis here, and then your alternative hypothesis is either here or here, and so it's on either end. So when we reject the null hypothesis, it could be either on the positive or the negative. They're just saying, hey, here's the null hypothesis. The alternative hypothesis is that it's not the null hypothesis, and it can go in any direction from there. That's your two-tailed. So above, when we said, hey, there's no correlation as our null hypothesis, and then our alternative hypothesis says then, okay, well, if there's no, then it actually has to be a negative. And that's a one-tailed test that we're going in that specific direction. Let's practice labeling whether something is a one-tailed test or a two-tailed test. For each situation, write down the null and alternative hypothesis and state whether the test is one-tailed or two-tailed. So practicing all of our vocab. The proportion of students at the college taking Maths SL was 72%. Livia wants to test whether this portion has changed. So the null hypothesis is that it has not changed. Everything has stayed the same. So we're going to write that. Our null hypothesis is that everything has stayed the same. And this is that the percentage, the portion of students at the college. So we'll say that P, our portion, has stayed at 0 point, or not 0 point, just 72 as a percentage. Your alternative hypothesis, and it says she wants to know, Livia wants to test whether this portion just has changed. So whether it's changed just means that it's not equal to 72. It's not saying, hey, we've gotten bigger than 72. Hey, we've gotten smaller than 72. It's just, hey, P is not 72. That's our alternative hypothesis. Yes, it's changed, or no, it's not. That means if it's the idea of just either it stayed the same or it didn't stay the same, is a two-tailed test, right? We aren't talking about getting bigger than 72. We aren't talking about getting smaller than 72. We're just saying, hey, has it changed? It's a more broad test. Okay, let's practice it again. Raphael has collected some data on the heights of trees and lengths of their leaves and wants to test whether there is a significant positive correlation. So here, the null hypothesis would be that there is no correlation. So H sub 0 there is no correlation between tree height and leaf length. So then the alternative hypothesis, because Raphael wants to test whether there's a significant positive correlation, that the taller the tree gets, the longer the leaves get. So then the alternative hypothesis would be like, okay, well, if there isn't no correlation, then there is a positive correlation. Between the height of a tree and the length of the leaves. I want you to go ahead and take a second and tell me whether you think this is a one-tailed or two-tailed test. Because the rejection of the null hypothesis leads us to very specifically a positive correlation, this is a one-tailed test. Teo wants to find out whether there's any correlation between the number of hours of homework done by a student and their final examination grade. So the null hypothesis is that there is no correlation. The alternative hypothesis is that there is a correlation. Just a heads up, as you can see, writing on this device just takes a lot longer. So I'm not writing out full things. When you're writing out your null and alternative hypothesis, you need to be very specific, right? You shouldn't just say there's no correlation. You should say there is no correlation between the number of hours of homework done and their final examination, versus the alternative is that there is a correlation of the number of homework hours done compared to their final examination grade. So be very, very specific. I'm just kind of giving you a general overview right now of what that is. Take a second, tell me one-tailed, two-tailed. This is a two-tailed test. All of our examples so far of one-tailed test have been correlation related, and I just want to show you that you could also just have a correlation two-tailed test where you're like, okay, either there's no correlation or there is a correlation. I don't really want to focus on whether it's positive or negative. I just want to show that there is some sort of relationship there. Okay, so we've talked about null hypothesis, we've talked about an alternative hypothesis, we've talked about your one-tailed and two-tailed, and so now we're going to talk about your p-value. So your p-value, right now we're going to just do like a very, very basic introduction to it. Your p-value, there's calculations that we're going to do to follow it, and that's not what we're focusing on right now. What we're focusing on right now is what do you do with the p-value when you get it. So write down here like basic intro. More to come later. Because as you probably know, we're going to be doing a lot of calculations on our calculator. Your calculator is going to do all sorts of like statistics and probability simulation things. And it's going to give you this p-value. And so what do you do with the p-value? Well, with the p-value, you compare it to the significance level. Significance level. And the significance level is it's represented as a percentage. And it's almost always in this class in IB, it will be 1%, 5%, or 10%. So at the beginning of the test, they'll be like, hey, you're doing this test, or at the beginning of the question, they're going to be like, hey, you're doing this test, you're testing your hypothesis, and we're doing it to a level of significance of 5%. 5% is one that I see the most. So what you do is you get this p-value, and then you compare it to the significance level. And the idea is that if you are less than that significance level, then you reject the null hypothesis. So let's write that down.